So for factoring this problem, of course, the first thing we do is multiply a times c, and then we have to figure out what possible numbers could go into that. And as you take a look at it, that means we should then think ahead here about what should I try dividing this 4,235 by. Should we try dividing it by 2? No, we shouldn't, because it's not even. Remember how we got that? We multiplied 35 by 121. The only numbers that multiply into those, 35 is 5 times 7. 121 is 11 times 11. So notice there's no 2 in that. So 2 is ruled out then. What about 3? Should we check 3? No, because there's no 3 that goes into it. Should we check 4? No, because if 2 doesn't work, 4 definitely won't. In fact, because 2 didn't work, we could rule out anything that's even. So we're saving ourselves a lot of time. Again, this is stuff we're just doing in our head, doing in the background so that we can find this number a little bit more quickly. All right? Should we check 5? Yes, because that was one of our numbers that we saw up here. All right, 7? Yeah, that's worth checking. 9? Well, 9 requires a 3, and 3 doesn't work. So for that reason, we could actually say no on 9. We don't even need to check the 9 either. And so if you're doing this kind of work in your head, you make it a lot easier for yourself to find the combination that multiplies to 4,235, but also adds to 132. And so we start thinking about which ones do I need to check then. What if I just start making a list of all the different numbers? Now, again, you're not going to actually write this out unless you really want to be super, super diligent about this, and that's okay, but this stuff's going on in your head. So we already talked about how we need to check 5, and we need to check 7. What would I need to check after that?
11.
11, yeah, because remember there were the 11s in the 121. And that was all the numbers we found there. But there's still some numbers that would be worth checking here. What's another number that could theoretically work? 15. 15 would not work, because for 15 we need a 3. And we don't have a 3 here. All we can do is utilize the 5, the 7, and the 11. So what's another number I can make out of 5, 7, or 11 without any other numbers?
1.
Well, what if I multiplied the 5 and the 7? That gives me 35. So that would tell me try 35 then. But there's nothing under that. Because, let's say 5 and 2 is 10. We wouldn't have to check 10 because it requires a 2. We wouldn't have to check 14 because it also requires a 2. Yes, it has the 7 in it, but it also requires a 2, which we don't have to work with here. And so these are just some hints that can help. So after 35, well, I could also check like 5 and 11, right? So that would give me 55. Or I could check 7 and 11. But I only need to check so far up, right? If you were wanting to know just how high do we need to go, remember the little trick is that you could take the square root of our number, the 4,235 there. If you take the square root of that, that gives us about 65.07 approximately. So that tells me that if I start checking stuff that's over 65, I'm duplicating work I've already done. So in actuality, these 5 numbers are the only ones that I would actually have to check here. And so just by kind of seeing a few of those things, you make your life a lot easier in doing this search. You make it a lot easier to find the winning combination because you don't have to check nearly as many numbers. Now, if you did check every single number, divide by 1, divide by 2, divide by 3, divide by 4, you're going to be there for a while. Because as we look down this list, if I just started dividing by 5, then divide by 7, divide by 11, it's going to take us the whole list. Our winning number out of this list ends up being the 55. And so it ends up actually being 55 times 77. Notice the 77 is that other number. It's another number that could be made just out of 5, 7, and 11. All right, now that we are here, we found our combination. we've done the big work of it. The rest of it is just going through the steps of the process and knowing the steps of the process. So if you haven't yet finished it out, I gave you the combination so we could split up B, finish it out from here. So to get to this next step at this point, remember I'm factoring out of the first two terms only, which gives me this. You'll notice I could divide both of these here by the 7 and by the x. So that's why I got to take out the whole 7x. And then we're factoring out of the last two terms, which is where we get this, because I can divide both of those by 11. So I pull the 11 out. And again, I know I did it right at this point because inside of the parentheses is the same for both. That's that confirmation that I've done everything right up to this point. And so notice what I'm saying there, where that's that confirmation, it doesn't mean that I just assume that this is going to be the same. I don't do the work for this one and then just plug that in over here. I'm actually doing the work of dividing both of these numbers by the 11 and seeing what I get out of it so that I can make sure that they are indeed the same. All right, and then once I've done that, I pull out that 5x plus 11 that is present in both of those terms, and what's left is the 7x plus 11. So then that's our final answer. So you'll notice in this case, when you multiply a times c, you get a very big number, negative 13,013. But again, the numbers that we use to get there, the 77 and the negative 169, there's only a few different numbers that we can use to get those. So if you kind of think about what numbers actually go into this, you're not going to have to search nearly as many as you would otherwise. And so in this case, I know that to get the 77, that's 7 times 11. And to get the 169, that's 13 times 13. So I don't need to check anything that requires a 2, a 3, a 5. We've really narrowed down the number of possible numbers that we'll actually have to check here. In fact, these are the only numbers that you would actually have to check in doing this one. There's only 5 of them that are possibilities, because after this we cross the square root, and so we'd be going backwards after that. And so one of those 5 is your winning number. Now, while you can still do this problem by brute force, where you're just dividing by every single possible number until you find the right answer, it would take a while, wouldn't it? Because our winning number in this case ends up being the 91. We would be at it for quite a while if we were just dividing by every single number between 1 and 91. Whereas if you think some of these things through, and again, you're doing this part just in your head, you're being like, okay, now what do I need to divide by? Well, I can skip anything even. I can skip all the multiples of 3. I can skip all the multiples of 5. Even if you just had that in your head as you were searching, you'd be able to go through and search very few numbers, comparatively speaking. And so it's just a way of kind of using what you already know about numbers and using what you know about math in order to be able to make your life easier along the way. All right, so when I divide by 91, I get 143. Then it's just a matter of getting the signs right. Once you get to this point, then we finish our process. We go ahead and finish factoring out from there. And so to proceed from here, I'm going to go ahead and start by factoring out the first two terms, and only the first two terms, and let's see what can I divide out of both of those. So yes, we can divide it by 7 then. And notice that both of those terms also include the x, so I also pull out the x. And so then that's going to give me the 11x minus the 13 when I actually do that division by the 7. All right, then I repeat the process over here with these last two terms. So I look at the 143 and the 169. Remember, the only way you get 169 is 13 times itself, or 1 times 169. Does 13 go into 143? Yes, it does. In fact, it goes in 11 times. So that means that since I can pull 13 out, I do so. So the 13 comes outside the parentheses. Notice it's not a 13x. because there's no x in that term. All right, so then I do 143 divided by 13, which is 11. So that's now an 11x minus, and then I do the 169 divided by 13, which is 13. And I'm saying it written this way on a lot of people's papers at first, but please remember that this is not all one term here. It's actually two separate terms. So since that was a positive 13 that we factored out, we still need to include the plus between them. Otherwise, what we do next isn't actually able to be done. All right? Now, remember, I did not get this parenthesis by looking at this one. I got that parenthesis by actually doing the division here by 13. That way, after I do that, I can take a look at these two and see whether they are in fact the same. And they are. And that tells me that I did it right. And since they are the same, and I know that I got it right, I can now go ahead and factor that same term out of both of the parentheses to get my final answer. And so the 11x minus 13 comes out front, or second. Actually, I wrote it second here for random reason. Let's just say the reason is to show that it doesn't have to be first. And then we got the 7x, and we have the 13 that is left behind because each of those are what was multiplied by it. And so notice that's what's left in the other parentheses. And again, the order of the parentheses doesn't matter.